Hi, everyone, and welcome to our talk on image optimization for NFT marketplaces and galleries. My name is Lawrence Naiman. I'm a customer success manager at Imgix with a focus on crypto and NFT websites. In this talk, I will show you how to optimize your NFTs using Next.js as the front end and Imgix for the NFT visual assets. In the demo I'll share shortly, we'll compare an optimized NFT gallery to an unoptimized one, and the huge performance differences between them using the Pagespeed tool from Google. To set the stage, let's say you've just minted an amazing collection that you want displayed on your marketplace or gallery, but the NFTs are taking a really long time to load and getting slower the more NFTs you add, which is causing, poor web page performance. One of the biggest reasons for this is that the weight of an NFT asset is typically much heavier than needed. And when displaying it on a web page, they drastically lower page speed performance, thus hurting the user experience. Unfortunately, due to a high volume of scammers and bad actors out there in the NFT space, it's especially important to nail the performance aspect down because bad UX is extra amplified in the NFT space in particular. A poor user experience can not only cause visitors to leave prematurely, but also cause the users to be quick to judge on the trustworthiness of the site and quick to label it sketchy. We know how tight the competition is right now and how quickly word spreads in crypto land. With so much growth in the past couple of years and the industry evolving a million miles per hour, you wouldn't want something like web performance to slow you down. On the other side of the same coin, you also want to take care of this issue in a future-proof and scalable way. So let's get started. This is the app that we just built. As you can see, there's a collection of NFTs here, cute little ghosts, and they look quite small. And depending on what kind of screen you're looking at this through, might be a little bit bigger, but in general, you would think that images like this shouldn't cause too much issues, right? They look like pretty simple art, very typical of like a lot of the NFT kind of collections that we see these days. And what I'm going to do here is just copy this. Oh, we already got it up. So I ran a quick page speed on this earlier. And what we found is, the performance score on desktop, we'll only do desktop, by the way, since 99% of marketplaces and galleries these days are not really mobile ready, but soon enough, the industry will shift towards that. So we want to just focus on the use case that captures, 95% of the audience here. But if you're familiar with PageSpeed Insights, it gives you an idea of what to improve on your site based on Google's recommendations to, get it better SEO and things of that nature. So really quickly, properly sizing the images is the biggest culprit here. It's adding 6.3 seconds to the load speed, which, is insane. And this is not even that bad. Imagine going on to certain sites that have, no optimization going on, tons of other folks going on. The site itself can really congest the network and reduce sort of like the speed in which you experience the gallery. So just looking here, it's recommending that we can potentially save tons of space. There's also another nick here where it's saying to serve images in next-gen formats such as WebP and AVIF. And if you've never heard of these before, these are sort of image formats that have been developed more recently in the past couple of years. And they allow the image to be compressed more without sacrificing too much on the quality, while still, creating that light file size. So this is the before. And just to prove that we're seeing the same thing here on the live site, and I'll share this at the end as well for anyone that wants to take a look at it themselves. We'll take a look at the inspection tool here. And first, let's go ahead and see how heavy this entire page is. All right, so we filtered down by images. Let's scroll up and get the sizes down here so we can see that all of these images that are in the gallery have been loaded. Some are JPEGs. This, we can ignore that, it's PNG, but all of them are JPEGs, right? Which is what we're familiar with and what we love. We love our JPEGs here in crypto land. And the file sizes are all, in the 200s to 300s and up. There are 31 requests. 30 of these were the actual NFTs themselves. And altogether, this created like a page load of 8.1 megabytes. This is pretty heavy, I would say, for images like this. We don't want that. So how do we go ahead and reduce this and get that page speed to be faster and lighter? So let's go into the after. So you can see it's still the same gallery. Some of the images have shifted around, but they're all the same still. So let's go ahead and inspect this one more time. Get the network tab, filter by images, refresh, and boom. So we have a huge difference here. A lot has changed. So first of all, we see that the file types have all shifted from JPEGs to AVIF. This solves one of the problems that we were dinged on here in terms of serving a next-gen format, serve as WebP or AVIF. And if you're curious, AVIF is even newer than WebP. So that's that. Oh, where did the inspector go? And the coolest thing really is the savings in terms of the file size itself. We still have these 31 images that have been loaded, but instead of being 8.1 megabytes, it's actually 261 kilobytes now. So that's pretty insane if you think about it. We went from 30 images being around 8 megabytes to now 30 images being the same size as one of the old images in the previous example. And let's take a look at what exactly is going on here. It's not just magic. So if we go before, so we saw that even this took a second to load. I'm going to look at what is going on with the images themselves. So if you look above where my mouse is pointed, you'll see that there's a couple of fields here. It says rendered size, file size, etc. So the rendered size is the size of the container here that the browser loaded, right? So why is the intrinsic size, the actual image itself, so high? This is because we haven't done any type of optimization whatsoever so far. So what it's actually doing is loading an image that's 1920 by 1920 into a space that really should be, around 168 by 168. This is creating a lot of unnecessary bandwidth to be used. And imagine this one image is just like that. But if you go to each and every image here as well, same thing, right? So it's not loading the correct size. Now, in the past, what you would probably do, or if you have some kind of other tool, you would have to create a ton of different versions of this image, put it into your code and have it account for every type of scenario, whether someone's on a desktop that's 30 inches, or if their browser width is, only half the screen or full screen, all of these different scenarios. And for someone that's probably not focusing on images all day, every day, you're going to want to kind of offload that hassle. And especially as you keep getting new images out or these different file types come out, you want to stay ahead of the game. So let's dive into how we used Imgix to get all of this optimization and hassle out of the way. So I'm going to expand this. Now, don't be intimidated by this block of code here. You'll be excited to know that none of this was actually done manually. It was all done automatically through one of our libraries. But as we hover over, we can see this time that, the rendered size, same container space, and this time it loaded an image that's 328 by 328. Now you might be wondering, wasn't it supposed to be 168 by 168? It's a good catch, but what's actually happening is different screens have different pixel density ratios. And so if you're on like a MacBook, those tend to be around DPR2, 2.5, something like that. So what it means is you can add a more crisp and heavier image without losing any sort of without compromising really on the quality. So the screen can actually take in more without losing anything in terms of the pixel ratio itself. So my laptop, my monitor has a DPR of 2. So as we can see, that's why the size that's being loaded in is twice as high as the rendered container size. So this actually fits perfectly. And how are we able to do this? This is the big question now. So let's go into some of this code here. And for those of you that are not code friendly, as a background, I have no engineering background. And something like this was actually very human accessible by someone like me. So I'm sure for folks out there that see something like this and get super intimidated, don't worry, we'll walk through this and it should be quick to stick. So this right here is the code for our app. These are all of the images that have been put in. And if you are one of those folks that are familiar with how to build web pages, obviously you don't have to do this all one by one like that. But I just did that for simplicity's sake. And let's take a look at the image tag here. So we see classic image tag in Next.js. You have the source, which is pulling in all of these images from here and not doing much else. Now, if we look at how we're able to do all of this optimization, we have the same page. This is the after page that we're looking at with the optimized images. And we can scroll down and again, look at that same image tag, but this time we've used an Imgix library, specifically our React library, to take care of that source set generation, which was this huge block of code that we looked at earlier. This is loading in a ton of different sizes of the same image, and the browser is going to go ahead and pick what is the best size to load based on what that user is kind of like interacting with the site with. So if they have a screen that's a lot bigger, or if they're looking on mobile and it's a lot smaller, you see like the size changed a little bit, this library will automatically pick what is the best size. And all that took is a quick import of the React library, added some size attributes here so that the browser knows what exactly to do in these different scenarios. And then another thing that we didn't really talk about, but these Imgix parameters. And this is what's really cool using a tool like this, is you're able to pretty much like modify the image and transform it without having to do any work beforehand. So like I mentioned earlier, in the past, you might have a bunch of the same image, but different sizes to load in different scenarios. With something like Imgix, you pretty much can do all of that in the URL and with a couple of lines of code. So what we've done here is we've added a parameter that will automatically format the image. So this is where we got the AVIF or WebP sort of improvement from the Pagespeed score. And then we added another parameter to compress. So this will compress the image, make it even lighter by taking out unnecessary metadata from the image itself and doing a couple of other cool things that will just pretty much focus on getting the image size to be lighter so that it can load faster. We have hundreds of different parameters that you can play around with. You can even do cropping. You can create an ellipse, for example, tons of interesting different things. And we can share all of that if you're interested in learning more in our documentation. But essentially, that's all that we did to really improve the page speed score from 68 up here to the after. I don't even think I showed this yet, but it went up to 100. And Obviously getting 100 on like a full-fleshed site is much harder than this, but again, for a website that just has images and not much else, the fact that it even had a 68 is already kind of funny to me anyways. But then second, you know, we got all greens here, not complaining about anything. We took care of, you know, the compression and the changing of the formats with a couple of parameters and a few lines of code. So yeah, that's pretty much the general idea of the demonstration here. None of this is financial advice, but it was web performance advice. I've always wanted to say that. And I will wrap things up with why Imgix. You know, obviously I work here, so very excited to share about it. But even if you're, you know, just having like a hobby tool or creating a pet project website, something like this could be really useful and save you a ton of time when you're working with tons of different images. You'll be able to manage your images through our UI that we provide that's free to sign up for. Like I mentioned earlier, we have these different parameters that can change the image, transform it on the fly without you having to do anything in Photoshop or anything like that. It'll optimize them, change the formats for you. And then we're also a CDN. So it delivers your images anywhere in the world, lightning fast, so that you don't have to worry about anything like that. So if you're interested in getting started with Imgix or have any questions, feel free to reach out to us. We have a YouTube channel where this talk should be up there shortly after. And then of course the documentation, if you have any questions about implementation or anything like that, should be all answered here. And then sign up for a free account. We have free tiers up to 1,000 images. So go ahead and play with it. It's really simple, and we have tons of folks ready to help out if you have any questions whatsoever. So thanks for having me here and for everyone that was listening. And have a great rest of FITC.